All right, we are looking at converting and comparing functions of different types. We're using it with different pizza chains. So, looking at our very first pizza place, Rocket Pizza, they have their pricing model listed as a table. X represents the number of pizzas, while Y represents the money that they'll pay us to deliver those pizzas. So 0 pizzas delivered, we get $28. 10 pizzas delivered, there's $37. 20 pizzas delivered, we get $46. So what we want to try to find is M, our slope. It's the money we get per pizza delivered. It's going to be a fraction. B, this is our y-intercept. It's what we get to start our payoff with. So our y-intercept is 0, comma b. Well, that one's the easy one. We're told what our y-intercept is right there from the table. They're going to pay us $28 to work for them that day. Don't have to deliver a single pizza, we get that $28. Our function rule is going to be based on our slope-intercept form, mx plus b. So we already know what b is. Our equation rule so far says this. What we have to find out now is how are they going to pay us per pizza. We're going to see that with the rate of change. So as our money increases row to row, we're going to compare that to how many pizzas it changes. So from 28 to 37, they're going to pay us 9. 37 to 46 is also 9. And on this side, from 0 to 10, 10 to 20, that's 10 pizzas. There's that constant rate of change. 9 over 10, that's our slope. They're going to pay us $9 every time we deliver 10 pizzas. Not the best deal. But that number gets to go in our equation right there. It looks kind of like an A. We need 9. Let's look at our next pizza place, Garlic Bob. So Garlic Bob has already given us the equation rule. So if we use the problem previous, we can kind of see how M was in front of the X, B is at the end. So Garlic Bob is actually going to pay us $16 to work for him. Don't have to deliver anything, he's just going to give us 16 bucks. But he will pay us $17 every time we deliver 5 pizzas. We can then use this equation to fill in the table right here. Our 16 is really 0, comma 16. We get to put it in the table right here. We deliver 5 pizzas. So Garlic Bob pays us $17, earning us $33. We deliver another 5 pizzas. He gives us $17. We've earned $50 at this point. We actually see this ratio work from first row to last row. If we were able to deliver 10 pizzas in one go, he would pay us $34 for the 10 pizzas, just like if we did 2 different deliveries. So the ratio still works out the same. Oops, I'm going to get rid of the purple here. Now for Todd Pizza, Todd told us that he'll pay us $25 and then $9 for every 4 pizzas we end up delivering. So we actually get to start with $25 without having to do anything. That's pretty sweet. And then 9 for every 4. So our function rule gets to be written 9/4 x plus 25. Filling in the table, we get to start at 25, and then we delivered 4 pizzas. So he's going to give us an additional $9. We delivered 4 more pizzas, another $9, another 4 pizzas, another $9, filling out our table. And then last but not least, Bo Joseph's Pizza is the graph that's on our page. It's this one I've included right here. I want to figure out these points in the table. I need to know, I don't do anything, how much is Bo Joseph going to pay me to work? So we find 0 on the x-axis, so that's right here. We go up to our line, and we see that he's only going to pay us $2. I think I used red earlier, so I'm going to use a different color. Let's go blue. Even though my line's blue, it's fine. Right there. I deliver 5 pizzas, so I'm not 1 pizza, not 2 pizzas, 3 pizzas, 4 pizzas, 5 pizzas. I go up. It's this coordinate point that I've left on the graph for us. He's going to pay me $24 after I deliver 5 pizzas. So I'm going to start with a $2 salary. He's going to give me $2 just to work for him and do nothing. I mean, compared to the $25, that's not a very good deal. But when I look at that rate of change, our slope, he's going to pay me $22 every time I deliver 5 pizzas. That is a killer deal right there. 5 pizzas, $22. This person would give me $4 for 2 pizzas. This one gives me 17, not bad, but 22 is way better. This person, I'd make 45 cents for 5 pizzas. That's nothing. So our function rule, let's put all the pieces together. And now that we have the function rule for every pizza place, we have the slopes, we have the y-intercepts, we can actually start graphing these. It's actually easiest to graph these equations using the table. The only reason why the table makes it easier, I'm going to switch this one to blue so it kind of matches up all my stuff, is because of the scale. Over here, each one of these boxes is actually going by 2s. So when I count up 1 square, 2 squares, 3 squares, 4 squares, I'm actually going up 2, 4, 6, 8. So trying to graph it by slope, counting up 22, 2, 4, 6, 8, 10, 12, 14, 16, 18, it's a lot different. Now, I don't have to graph Bo Joseph's, so we're going to graph the other ones. So here's my graph. I'm going to go back and I'm going to fill in our tables with the data that we have. This one's 16, 33, 50. Bo Joseph's, well, now that I have a chance, I'm going to change it to red to match my lines over here. This was 2 and 24. Todd Pizza will be in purple. We had 25, we had 34, 43, 52, and then last but not least, we'll put Rocket Pizza in blue. It's already plotted for us here, so I don't need to do much about it. All right, let's start with Rocket Pizza. 0, 28. I then have 10 pizzas. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 37 is halfway right there. If I was on paper, I would grab a ruler. Since I have the computer, I'm going to use my straight line tool. And right there is Rocket Pizza. I'm going to label it way over here with an R. So if we look at just these two lines, Rocket Pizza is the better option from 0 pizzas to about 7.5 pizzas. After this point right there, Bo Joseph's becomes the better option. You're making more money for the same amount of pizza. Let's graph the rest of them. Let's move on to Garlic Bob. Garlic Bob starts at 16, so 20, there's 16 right there. My next point is 5.33, so 5, then 30, 32, 33 is right there. Grab my straight line tool, change the color to green. Garlic Bob, it's right there. I'm going to move myself now. Drop myself down over here. Go back, finish drawing my line because it should go all the way from one edge of the graph to the other edge of the graph. Let's label it. That's Garlic Bob. Label with a G. So now when we look, Garlic Bob, according to the other 3 equations, becomes the best option right here at about 5 pizzas and stops being the best option at 13 pizzas, roughly. Let's graph our final line. Our Todd Pizza starts off at 25, 4.34, and then 8.43 if I want to plot that one, 8.43. It's right about there. So I will graph my purple line. I think that's the right shade of purple to match up with everything. Right about there. And that is Todd Pizza. All right. While I'm looking at this graph, I'm going to kind of walk through it. Rocket Pizza, this blue line, would be the best option for pizza if I sold 0 pizzas to about, we'll overestimate, to 2 pizzas. Right there, that first range from 0 to 2, that's the best option. The minute you sell more than 2 pizzas, Rocket Pizza is no longer the best option. It actually switches. Todd Pizza becomes the best option right here. From about 2 pizzas to 8 pizzas. So if you were able to sell 2 to 8 pizzas, you would make more money at Todd Pizza than the other pizza places. Then right here it switches over. Garlic Bob becomes the best option, at least for a little while. So Garlic Bob from 8 pizzas to about, what is that, 13? 13-ish? About 13-ish pizzas is when Garlic Bob is the best. Then after that, Bo Joseph's is the best. Everything after 13 pizzas. 13 to infinity. You would make more money for that amount of pizza at Bo Joseph's more than anybody else. Just to help us kind of visualize it even further, if the graph hasn't helped us, if we were to pick 20 pizzas, if I were to sell 20 pizzas in one day, looking at our rules, so this one was, Rocket Pizza was 9/10 x plus 28. We know what that one is. Our rule for Todd Pizza was 9/4 x plus 25. and Bo Joseph's was 22 5x plus 2. I'm going to plug in 20 for x. So x equals 20 pizzas. I deliver 20 pizzas in one day. So I'm going to put the 20 in here, the 20 in for the x right there, the 20 in for the x, 20 in for the x. When we calculate it, 20 divided by 10 gives us 2. 2 times 9, is 18. 18 plus 28. That would give us, what is that? 38. $46 made for delivering 20 pizzas, which we already knew in the table right there. I didn't even have to do the work. Over here, the 20 divided by 5 gives us 4. 4 times 17, so that's 40, plus 28, that's 68. Plus the 16 we're given just for working that day, so that's 78. That's $84. Much more of a difference. Todd Pizza, 20 divided by 4 is 5, so that gives us 45 plus 25. That gives us 50. $70 for Todd Pizza. And last but not least, 4 times 22 gives us 88 plus 2. We would make a grand total of $90. After that is what we see right here. Bo Joseph's, anything above 13 is the best price. I can redo it. I'm not going to for the sake of timing on this video. But if you pick a number between 2 and 8, you'll land somewhere right here, which we see is much higher than any of the other lines. The last questions on this page that we have is I want to sort the pizza places by the slopes. So, by M. This slope was 9/10. This one was 17/5. This one was 9/4, and this one was 22/5. I want to make the smallest one. If we don't see the change in size or the difference in size between one fraction, it could help us to convert it to a decimal. 9/10 becomes 0.9. 17/5 is 3.4, I believe. Yep. 9/4 is 2.25, and 22/5 is 4.4. Which one's the smallest? Rocket Pizza. Oh, now I got to move myself again. Put it back up here. The next smallest is Todd Pizza. The next smallest being Garlic Bob's, and the last smallest, Bo Joseph's. We see this scenario play out on our graph as well. Least steep, next steepest, next steepest to the very steepest line. Right there. The next question, we want to sort the pizza places by our y-intercepts. That was B. This one was 28. This one was 16. This one was 25. And this one was 2. Well, very easy. Lowest, Bo Joseph's. Next lowest, Garlic Bob's. Next lowest, Todd Pizza. And last lowest was Rocket Pizza. Yes, they're exactly backwards. That's how I could get our lines to where each individual company was best at some point. Best here, then here, then here, and then final. That way it could be a compelling problem. We've already figured out what range of pizzas that would force you to work for Garlic Bob. You would want to work for Garlic Bob when you sold 8 to about 13 pizzas. And that's comparing functions.